Swayam Prabha. Digital India. Educated India.
So, welcome students. Today we will be discussing another aspects of underground mine transport, that is the winding operation. You know, those who have seen any mines or those who have ever been any opportunity to see some films on mining or videos on mining, particularly underground mining, you might have seen the materials and man, they are being lifted within a cage. So, as this picture which you are seeing is a very old picture, almost a signature picture for underground mining, where that cage within which this people were brought, or the materials loaded in a mine car are put inside a cage and then it is lifted to the surface. So, depending on the container by which the material is brought up or the arrangement of the system, we have got two distinguished systems called cage winding and skip winding. So, this today we will be discussing about what is this cage and what is this skip and how they are exactly placed in a mining shaft and how that whole winding operation are carried out. As such, this whole winding operations, their calculations, their design, all is a vast area again, but here our purpose is to understand the basic of it, what it is, so that those of you who are interested can take up some work on it. So, this introductory lecture, let us try to see what is exactly this winding. You know that this materials from underground, they can be brought by this cage or skip. Now, you know that whenever there is any underground mine, suppose this is your surface, and then you want to that maybe you are having your coal seam somewhere, that say if your coal is lying at a depth somewhere here, it may be lying like in a coal seam, this coal is lying over here. So, normally what is done in your method of mining, you will be knowing about it, that we can go vertically, we can access, you can have a vertical access to this pit, that is called your shaft. When you make a shaft, then this one, if it is shaft is going through this, then you to get this coal from here, you will be making some horizons. So, that means what is done here exactly, you can see that basically you are having this shaft which will be going down here, this shaft will be going down like this, and then from here it will be going entering into the mines, that is where there we are telling these are the roadways or gallery or drift that will be going over here. At the top of it, we will be having a structure called your headgear structure. In this headgear structure, we will be having a sieve. From there, we will be lowering a winded rope, and then we will be suspending a cage or skip over here. Now, when this cage is coming down here, then from here this part will be connected with a rail, it will be connected from this side. So, the mining car which has been brought here by your rope haulage or by locomotive haulage, this car will be pushed and kept over here, or the people whoever want to go, that persons also can come over here, and then it will be lifted, and from here when it is coming up to this level, from here it will be taken up through this, and then you know that in the pit top layout where this car will be going, and then suppose they will be giving to a hopper, from here it can go to a conveyor belt or it can go to this to the users, and this car will be returning back to these portions. You may have a creeper over here and then putting the case again, this case which was here, it will be lowered down and this will go on. So, sometimes instead of this case there is a skip which is a container. This container will be taking the material from underground directly into that skip, and that skip will be brought to the top. So, that means your this you can see here that mine case, this figure which you have seen over here, this is a case, and that case it can be number of decks. So, this is a triple deck, that your double deck case over here. So, that you can just below this another layer, the people can be in boats, sometimes in one layer you can have the person standing, another the car standing, and the whole thing will be lifted. You can see these tracks are laid, so that when the mine cars are coming, they will be putting over here. So, these case, the locations they are exactly in within that. Now, this they are being suspended by the wear rope and a suspension gear over this vertical shaft. If any snaps takes, that whole thing will fall down. Now, here you can see this cage part, it can be of different type. It can be an open type, semi enclosed type, fully enclosed type, sliding type, folding type, roll up doors. That means, depending on this is a that particular location of the mine, what is their technology available, what type of materials available, they will make it. If you see in 18th century, 19th century, they were made all these things with wooden case, and they started dropping them by manila rope. That was the starting of the industry, and later on they are suspended by wear ropes, and this lot of technological development has taken place. And this case which can be now, it is a well heat treated aluminum and steel, that is giving a sufficient strength. It could be, objective will be, it should be as light as possible, at the same time it should be the strength as required for with taking the load. And because the one of the most important thing is, you will have to optimize the energy. More heavier, more weight means to lift and lower, you will require more energy. So, you will have to see that what is the minimum weight of material required to make the case, and also that the case suspension, how you are exactly on the rope you are suspending, that is very, very important as a safety. At the same time, when you do, all the mining engineers, they study this winding system and their safety arrangements very carefully, because this is the exactly the lifeline of an underground mine, because if the winding system is not working, you cannot produce. So, here this case, within the case you will have to have the mine car, and then you will have to suspend it, and then it will have to be lifted. So, there is a wear rope, this steel wear rope, which is in the rope haulage and all also. So, this wear rope will have to be connecting to this cage, and there is a, these are the suspension chains. This suspension chains, they will be having a shackle on which this cage will be suspended, and then there will be a triangular plate which will be connected to a turning eye, and here there will be a safety hook. This purpose of this safety hook is, if your because this wear rope will be going to a drum, winder drum, where it will be this exactly at the whenever there will be this rope will be coming like this. Suppose this is your sieve from where you are suspending the cage here. Now, this sieve, this wear rope will be going, and then it will be wound on a drum. It will be wound on a drum, and there will be number of turn over it depending on the depth of the shaft. Now, this wear rope, now when it is going, suppose when your this is driven by your this motor, this winder drum will be, it is mounted on a ground or maybe on a tire, and it will be coupled with a gearbox, and then it will be coupled with a drive motor. Now, if this motor is control is not there when you are winding, then if your brake is not applied or the brake is failing, then what will happen? This whole thing will be going, and that sieve, where this sieve is mounted, at that point it will hit. So, at that time there will be a disaster. With such a momentum, if it hits, it will break down, and that is why what is done, this safety hook, there is an arrangement that when it is getting overwinding like that, at by arrangement with this hook and a safety plate, that rope, when it will be passing a particular area over this, when it will be going a particular level, this rope will be going, they will allow the rope to go, but the cage will be kept suspended over here by this safety plate, so that the cage do not fall, because if the cage it falls, then it will be going down to the shaft, and that will be a disaster. So, for all this reason, what is done, that you will have to have this suspension gear, which is having this as I said, there is a safety arrangements. At the top of it, that rope will have to be terminated to this through a couple block, and above it the rope is terminated with a wedge type of couple. There are different types of this rope termination system, that is white metal couple, wedge couple, that is your this thimble couple, depending on that these arrangements are made, so that your cage is suspended. Now, that suspended cage can be brought within the shaft. You can see here in this diagram that your cage is suspended with this wear rope, which is coming to your this bank level, where there will be the cage. From the cage, your mine car will be taken out for dumping the material for the next transportation, and then there is a level to which there will be the safety hook and other safety appliances will be placed, and this sieve is mounted over here, and this is the drum over here. Schematically, you can see this drum winder. This drum can be a single drum or it can be a double drum. In the double drum means there will be two rope, one, that means instead of one cage we can have a two cages, and one, the loaded one, when it is coming up, the unloaded one will be going down, as because both are connected to the same shaft. So, there will be some power balancing. That means, because that one which is going down, it will be exactly also helping in getting this your loaded one to come up. So, that way we can have a double drum or single drum winding system with a hoist rope, and this is called your head gear structure. This is a back stay on which it is there, so that you can make it stable. They are designed considering all the wind load and structural load whatever is required, and then we are having that sheave over which this wear rope or hoist rope is going. So, this is a cage winding system, in which that cage which you have seen is connected over here, and from different level it can be connected. There are lot of technological arrangements are here for arranging the safety, convenience, and how it will be placed over here, so that it will have a guide rope through which exactly this whole cage it should not suspend, so that the dynamic load will be increasing. Your this wear rope, it should be always with a proper tension, it should not kink, and that wear rope damage should not take place. That is why there will be a continuous wear rope monitoring system, that if the rope is getting weakened, we will have to replace it, that what interval, how it will be replaced, all are regulated by the mines regulations and act. So, these are the things exactly you should keep it in mind, and that winding I have said that by a drum winder, instead of this, what can be done in a drum, you can see here that lot of winding of this your wear rope is here. So, that they are wound and unwound, and always you are keeping some rope over here. But there is another system in which you can see that this rope is continuously going and below it is returning over here, that single rope, there is no extra winding drum, that extra rope is here, and this drum and this rope, they are exactly you are having on that friction, you are driving this drum through that friction, it is transferred to this system is called a Coipe winding or friction winding system, only it is without having any turn on the drum. So, instead of a drum, it is a pulley, it is a rope and pulley arrangements, and here that cage which is suspended or skip which is suspended, at the back side there is the rope and this is exactly moving. So, this type of system, here you can have this one cage, one skip is here, another is here. Here this rope connecting them together is also called a balance rope. So, this type of system is also, this is called a Coipe winding. In most deeper shafts, when you go up to 2000 meter, at that time this type of shaft is there. If you go say in Tata Steel's Zamadoba mines in Basicial, you will find this Coipe winding is there. There are a number of mines, I think even if in the some uranium mines, they have also the tower mounted Coipe winding system, which is a very standard in the industry. Those who of you who are more interested to it, you can study, you can make some case study of this, lot of interesting, each and every component, a lot of study can be made out, but you must know as such, that is and what is a friction winding, what is a drum winding, and the general purpose and description of the system, I think you can describe it. Now, coming to the skip. Now, this skip you can see here, it is unlike the cage, it is a container. You can see here it can be a small or it can be very big, it can be of 2 ton capacity, it can be of 10 ton capacity, depending on the requirement from here. Now, you can see here that this skip, which is this will be exactly suspended by the winding system, whether it is a Coipe or drum winding, that will be suspended from here, and they will be guided by guide shoe, rail or rope, and then they will be taking up the material will be loaded, it will be inserted through this point and they will be discharged from here. Depending on how it is discharged, there are different type of models of skips are available. So, in company like FL Smith in India, they also supply, they manufacture it. Now, these are some of the things why you should see the historically how it has come, and then we can think of how the engineers think for solving a problem where there is a difficulty. So, this type of devices were designed from the very primitive one it came. Say first a Kimberley, a mine's name only, under that they got an overturning skip. So, this skip is nothing but it has got a that you can see this side rails, and then this one here this that you can see a modern FL Smith this overturning skip over here. Now, they have made an arrangement that the material will be loaded over here, and then this loaded material will be lifted, and when it come at the top, they make an arrangement that by pushing this it can be given a overturn, and then the material will be taken it out. So, this type of system, buckets are very small, only nearly about 4 meter cube of material or as less as 1.32 meter cube of material, it will be coming over here and then they are unloaded. One problem is, if the material is of sticky type and all, that when you are taking it overturning, all the material may not come out. So, then what will happen? There will be some dead weight coming inside the bucket, inside that your box, and then it will be coming up. So, a dead weight will be there. So, the energy you are spending, that your productivity, that amount of material which will be lifting will be less, that type of problem is there. Now, this overturning skip, there could be, how you can see over here, there is a, in the skip, a guide roller, a skip roll is there, and then this skip bucket. Now, you can see by the side of it, we have got this dump roller arrangements. When it is coming to the top, it will be brought over here, and then when it comes to the dumping point, at that your skip roll plate, here it get moved and that whole matter become your upside down. From this trunnion point is here, from the trunnion point it gets, and then the material goes out. This type of overturning this skip. So, you can see that component wise, this is your skip roll, here the skip bucket, here is your dump roller, and you have got a safety latch placed over here, and there sometimes could be a slime duct. So, if whatever is sticky and all that thing you wash, then put it something, you can open it out, the bottom portion also can be cleaned by this slime duct. So, this is how, when is your skip is going up, it will be going like that, that skip has gone up over here, and when this is coming up to this point, you can see it is over there, this skip roll, it has gone up. Now, that skip is with the help of your this pivot safety latch is there, at this point it is getting detached and it is coming over here. Now, when this will be lowered down, and then when it is lowering down like this will again become vertical, and then it will be coming over here, it will go down at the sub or the inside the mine, then again the material will be loaded from this top. So, now you have, this is a how a overturning type of this skip works. Now, you can see there is another type of skip, that is your front dump. In the front, they have got a your hinge is there, a door part is there, it will be just from this door is closing system, and the material is loaded and it is coming over there, and then at the discharge point they will be discharging like this. So, we can have different type of your, that is your front dump skip, or that their basic importance or the problem of this type of skip is, because there is a mechanism, a lever mechanism, your spring mechanism which is working, they will require continuous maintenance. If you do not maintain, then their closing and operating will be difficult. There is this your swing out body, you can see here, this is a skip bucket. Now, in the skip you can see when at the loading station in underground, the material is brought inside this by means of a chute. Then when the material is coming, you are keeping your this sector gate of the skip is kept closed. Now, when they will be coming to the up at the your dumping position, at that time your this gate, it will swing for opening, and then the material will come out of it. So, this is that it is coming from here is your sprout through which the material will be coming and material will be going like this. So, a mass flow will have to take place. We need to see that inside this surface, sometimes if the material is sticky, you may have to keep a liner, or so that the material flow well, as you have seen in bin and bunker discussions we made it. So, that your skip is the device which is going up and down the shafts, but it is loaded there. Now, can you notice one thing here? When you have used the skip, you are lifting the material only, but when you are using the case, all the time you are carrying out the mine car inside the case to the top. So, depending on if your mine is to produce your 300 ton per shift, then for 300 ton to carry with those 2 ton capacity cars, a large number of mine cars will have to be accommodated inside the gallery, and then from the face you will have to transport. And then some cars, some of the mine cars will be always at the top, and that is why total number of mine car required will be much more. But here that car is not coming up. So, there wherever they will be going in the underground only to the loading position. After the loading position, only the material will be lifted. So, that is why it is exactly capital investment. Of course, we will have to see, because the cost of the skip will be more than the scope of the cage, other arrangement is there. But if you see the operational cost, because of you will not require the many cars to maintain, so many people will be reduced, because at that for the pit top layout you whatever the manpower you are using, that could be released. So, those comes under your techno-economic calculation or techno-economic model. If you want to develop for the underground mine, you can consider that. Now, there is also another called your bottom dump skips. This is another type of skips. Here again the loading is done, and then from the bottom that material will be coming out. This one you can close over here at that when at the loading position, they will not be, it will be kept in a closed, that when at that your unloading position at the shaft top, when it will be coming, this will be released through a lever, and then we will make a chute and the material will go out. So, similarly you have got some arc gate. Here exactly you have got the door, which will be a opening and closing by an arc. So, this type of skips are called arc gate type of skips. So, you can see over here how things get innovated. That concept was there, that there will be a container which will be loaded by material in underground, and it will be brought. Now, you can imagine now that whether you can make a tabletop model, if you are putting it there, the material you are fixing, how they will getting unloaded, how many, whether it will be a lever actions will be there, or whether it will be a sensor, electronically sensor sensing and then controlling at in which way, or whether can you for a sticky material, if it is coming inside cleaning, can you have an ejector blade, can you use some hydraulic systems at that unloading system, so that you can operate it to do the unloading operations very quickly, so that the cycle time required in that can be reduced. So, those type of innovations still can be there, because how you can do the whole skip winding process as an automated one, developing a simple that your tabletop model, and that should be the spirit of all engineering students. By just having this outlook and overlook, now you should come, you should think of your, take your the AutoCAD or take your DrawWorks, bring up your this set squares and scale and pencils, draw a schematic diagram, think of how it can be fabricated, do it over there. That is the spirit of learning engineering for developing things. Now, that skip, if it is coming, how you will be, just like case you have suspended there, but in case of skip you will have to make some extra excavation underground, where that skips, that mine car will be bringing over here, and that tippler which was there for your in the pit top layout, I told you about a tippler where this car is tippled. Now, that tippler will be giving to a bin or a chute here, and the material will be guided to the skip. As in the previous figure we have said that skip has got a top where you can put the material down, and once it is filled, there you can think of automatically it will be at that your gate, it will be giving a signal to the winder persons, okay, my skip is now filled. They will start winding, and then the material will go up. When it goes up, it will be going up here, it will be brought, and then it will release the unloading, maybe it is a bottom discharge. From there the material will go to this hopper, below that we can have a conveyor belt, or you may have truck, by whatever way you take it. So, this is one simple system. Sometimes it may have got a different type of system, in which the skip can come up and then it can go a little bit turn, and from the top itself it can unload the material and go. So, these also lot of options and can be innovated. So, you know here the basic components of a skip winding system, where we are having the main hoisting drum, and that from here the hoist cables are there, which is going to that skip, which is connected over here. It is at the loading station, it is at the unloading station, because in a coupe winding, one loading one is when it is there at the bottom, unloading will be there at the top. That is the length of the rope will be managed in that way, so that there is a proper positioning is done, and then this whole head frame or head gear is there, and then we have got the loading chute, and there will be your bin, and the bin where the material will be given over here. So, this is the way you can describe now that what do you mean by a cage winding system or a coupe winding system. Now, where it can be applied, even in some surface mines also, instead of making your truck to move all the around this is the ramp and all that thing, they go over here. If your material is to be taken over here, and from there you are taking a rail, or by conveyor you can take up from that bottom, you can load into that skip can go up over here, then give a overturn, and then it will do. So, sometimes you can think of in some of the mines, if that is instead of travelling say more than 3-4 kilometer, if by doing 100 or 200 meter only your depth of the open cast mine, you can have this skip winding system, and that will be exactly making this economic. So, sometimes whether in the mines you can reduce the number of dump trucks which are required, if you are that, but only thing is there, you will have to have many of it, because if you are taking a say 270 tonner dump truck, you are applying in a very huge capacity of mines, there you cannot have this type of system. But there are many mines in which our production capacity is less, many of our some economic minerals and some of the quarries where small trucks and all, their diesel can be saved. All things are whether technical feasibility and economic viability, and need to compare. And as a student, you should develop the econometrics model for taking out this, after properly understanding that what are the technology involved, how much capital investment will be necessary, how much operational cost, and this normally in the final year when you will be studying about the mineral economics, you should take this type of problem as your case study. Now, you can think of when you compare the skip winding and cage winding. So, as I said, the skip winding is best suited for deep shafts for high output targets, which keep the ratio of the payload to gross load of loaded skip is higher. That ratio it can go up to 0.6 in case of your skip winding, but in cage winding it goes up to 0.35, because your that mine car it has get its own weight. As the mine cars are not to be raised to the surface, number of cars required at the underground is less, as I already told you. Skip requires less manpower, that also I told you, and then automatic loading unloading is possible. So, you can improve because of the automations, you can get the cycle time is less. So, exactly your hourly production capacity can be improved. Then skip needs separate arrangement of man and material, it will require more capital investment, and the most important difficulty or the difficult problem is, if your mine coal, if you are taking out by skip, but in the coal seam there are some darts coming, that band is there within the seam. Now, you cannot separately load and take it out. In case of your cage winding, those dart can be put in a car, and then when they are coming at the stop, in the stop those cars can be separated out and you can easily unload to a dirt tippler, but here because it will be going in that same case with the same systems, that separating the dirt coming from the seam is difficult over here. So, another thing is sometimes with that skip, when you bring the material while unloading, they fall a higher, the height is more. So, now you can find out that is exactly if at the time of unloading material to material impact as well as the material to the surface impact, they may get pulverized. If they pulverize, there will be more coal dust will be coming up. So, that area on which it will be there, if you are not taking proper ventilations and all, there could be a situation of coal dust explosions, and also in the atmosphere those fine coal particles dust will be going, that the persons working may be having the risk of getting pneumoconiosis. So, there are certain disadvantages as well, which you need to, when you want to go for a detailed study, you should see over there. This subject is vast, lot of things are there, but I hope I have just introduced what is a case winding and what is a skip winding. Lot of informations are available in different websites, but I suggest you read either Mr. Ghatak's book Mine Pump Haulage and Winding for knowing about how exactly the handling of liquid or this our solid is being done, Ghatak's book gives, or that Professor M. A. Ramlu's book of mine hoisting, but that is published by White Falcon Publishing, is a very good book giving a very comprehensive and good explanations of what the technology is. So, if you are interested to know that what is that, how material is transported from the underground to the surface, and this book I always refer, that is the mine hoisting, which is based on Professor Ramlu's experience in German mining, that is at the time when his whole experiences he has brought from the German mining, and that is all included in this mine hoisting book. I ask you to do, but the other book like your this mine winding and transport by Wakars, this book is a, though it is an old book, give the, you can see that how historically the things are there. So, I request you please go through it. Cages and skips are established practices in material transport from underground mines. Skip winding may be useful for in certain open cast mines also, and techno-economic feasibility study for determining the applicability of the system for certain specific applications could be very useful, and undertaking designing of a cage or skip system could be an useful learning exercise, and you can apply what are the mechanical and structural engineering you have learned in your first year and second year can be applied for designing such type of systems. With this, I stop here for the discussions on underground mine transport. Thank you very much.